Hi, today I'm going to continue from logistic regression, which I have already introduced in very short in the beginning of data science course. So here in logistic regression, you are quite familiar that it is a statistical method used for the classification of problems, specifically when the dependent variable is dichotomous or binary, or we also call it as discrete, and it models the probability of a binary outcome in the form of yes or no based on the input variables. Instead of predicting a continuous value like linear regression that predicts the probability of an event occurring, which is then used to classify the outcome. For example, here you can see two groups are available. One is paid group, another is unpaid group. So such kind of classification can be easily done by using logistic regression. So the key concepts of logistic regression includes binary outcome, that is the 0, 1, or sometimes it is also in -1. Then probability prediction. Logistic regression predicts the probability of an event happening, which is then used for classification. Then it is sigmoid function. A sigmoid function or logistic function is used to map the linear combination of input variables to a probability between 0 and 1. Then the next term comes maximum likelihood estimation, which I have discussed in the last class, very well defined way that uses maximum likelihood estimation to find the parameters of the model that best fit the observed data. Then finally, it comes to interpretation, how to interpret the coefficients, p-values, and odds and ratios. Now, how it works, it takes input variables, linear combination, sigmoidal transformation, and finally the classification. So after that, you need to understand some of the examples, like predicting whether a customer will click on an ad, yes or no, based on factors like age, income, and past browsing history. Determining if a patient has a disease based on symptoms and medical history, classifying emails as a spam or not a spam. Then logistic regression is a supervised machine learning algorithm in data science. It is a type of classification algorithm that predicts a discrete or categorical outcome. For example, we can use a classification model to determine whether a loan is approved or not based on predictors such as saving amount, income, and credit score. Example graph here, it has been taken from the Wikipedia. So this is for logistic regression curve best fitted to the data. The curve shows the estimation probability of passing an exam versus hourly studying a scalar independent variable. Now, if you want to understand the potential differences between logistic and linear regression, then you can easily understand, and you are quite familiar. I have described it in a well-defined way, that is linear and curved lines are one of the main difference, or logistic kind of line, then used to solve the regression problem, linears, and used to solve the classification issues, that is logistic. So estimation, it estimates, that is linear. Regression estimates the dependent variable where there is a change in the independent variable. But here it is different. It calculates, the logistic regression calculates the possibility of an event occurring. Again, linear regression output value is continuous, while in case of logistic, it is discrete, that is 0, 1, or -1. Then linear regression is a straight line, while logistic is a S-shaped curve or sigmoid function. And the example of application of linear regression is in predicting the GDP of the country, while the logistic regression example includes predicting whether an email is a spam or not, yes or no kind of examples. Now, both linear and logistic regression uses statistical tests to evaluate which predictor variable meaningfully impact the outcome. The techniques such as the t-test and the analysis of variance, that is ANOVA, or likelihood ratio tests for logistic regression generates p-values for each coefficient, which helps in assessing whether the relationship is statistically significant. A low p-value that is typically less than 0.05 suggests that the variable contributes meaningfully to the model. We also evaluate the goodness of fit, how well the model explains the observed outcomes using different metrics depend on the regression type. Now, there are some more terms which you need to memorize from the previous class, that is overfitting, underfitting, and final best fit, that is optimized fit. Then it is regularization and feature selection. All these things I have discussed in detail, but overfitting and underfitting, here again you can see in the figure how the underfitting data, that is the first subfigure on the top right side, and then last right subfigure in the top right side is overfitting, while the most optimal fitting is optimized fit. Then it comes to the regularization. Regularization is a method that adds to a penalty term to the loss of function to prevent the overfitting in machine learning. And then if you want to go for feature selection, there you need to go for grouping, classification, and over and underfitting issue sort out, and finally go for optimized fit, and final the feature selection takes place, that is final subset which you need to predict. Then it comes to the linear regression, saving credit score. Then to contrast the two models more concretely, consider a linear regression scenario where you can predict someone's credit score based on the features like their current saving, and then the model could look like this one, and the figures somehow it could appear here. So then it comes to logistic regression under the hood, like linear regression. So sigmoidal function basically is here. So this is regarding the, for example, the example includes the loan could be proved or not. And this is quite also similar. Then it is something called the sigmoidal transformation, allows us to make a binary prediction for the use preceding use case. After applying the transformation, the value of x can take the infinite value. Y will be confined to 0 or 1. And here you can see clearly odds, log odds, odd ratios, coefficients of the logistic regression, then maximum likelihood estimates, which was discussed earlier. Then odds compares to the chance of an event occurring to the chance it not occurring, which you can see here. Then log, it comes to the log odds. That is, for example, P of X represents the probability of an outcome. Then the odds of X are defined as it is mentioned here. And this is very simple probability equation. Then you need to understand in logistic regression log odds, which is also known as log it. It is the natural logarithm of the odds of certain event occurring. It is a transformation that converts the probability of an event into a value that can range from negative infinity to positive infinity, which is useful for modeling with linear equations. Then now, after this, you need to understand how the equations could be represented and how it can be converted to some other simplified form so that you can go easily for coding into Python, Perl, or R, or MATLAB. Then what is odds ratio? The odds ratio quantifies the change in the odds of a binary outcome for a 1 unit change in a predictor variable, assuming all other variables remain constant. It's calculated as the exponential of the regression coefficients. That is very simple way of coding in R, Python, or MATLAB. An odds ratio is greater than 1 indicate the increased odds, while an odds ratio less than 1 represents the opposite, that is decreased odds. Then it comes to coefficients of the logistics. So coefficients represents the change in the log odds of the outcome for 1 unit change in the predictor variable, holding all other variables constant. A positive coefficient indicates an increase in the log odds, while a negative coefficient indicates a decrease. These coefficients are crucial for interpreting the relationship between predictor variables and the probability of the outcome. Now, there is a term categorical predictors that is very important. So, where you need to go for categorize by using 0, 1, yes or no concept. So here you can use these categorical predictors, which are handled by creating dummy variables. These variables represents the category of the categorical predictor, allowing the model to estimate the effect of each category relative to the reference category. Essentially, you convert a single categorical variable into multiple binary variables. Now, maximum likelihood, which was discussed earlier a lot. So, is a method of estimating parameters of an assumed probability distribution given some observed data. This is achieved by maximum. This is achieved by maximizing a likelihood function so that under the assumed statistical model, the observed data is most probable. The point in the parameter space that maximizes the likelihood function is called the maximum likelihood estimates. The logic of the maximum likelihood is both intuitive and flexible, and such the method has become dominant means of a statistical inference. Now, there are three types of logistic regression. One is binomial, that is two classes, binary, 0 or 1, multinomial, more than two classes, as you can see here. Then it's ordinal, that is more than two ordered classes, that is low, medium, high. And then you can think about the use of logistic regression, for example, disease prediction in health sector, diagnosis, treatment, effectiveness, epidemiological studies. Then in finance, you go for credit scoring, fraud detection, insurance risk assessment. Then in marketing, customer churn prediction, ad click through rate prediction, then customer segmentation. And finally, if you want to summarize the logistic regression as a Python cheat sheet, then you can understand in data processing, feature engineering, model building, and model evaluation. And finally, the key assumptions of for implementing the logistic regression, that is, you can see here the dependent response variable is binary or dichotomous or discrete, little or no multi-collinearity between the predictor explanatory variables, linear relationship of independent variables to log odds. It requires a sufficient size of samples, then no extreme outliers are present here, and it should have independent observations. Now, here there are some summarized understanding of the logistic regression. That is purpose. It is used for the classification and predictive analytics, binary outcome prediction, machine learning, probability estimation types, three types, binary, multinomial, and ordinal. Then key assumptions, variable independent of each other, raw data, unrepeated, linear relationship of variable outcome, sigmoid, significant sample sizes, variables represented by binary categories, applications are vast and wide ranges. For example, optimization, strategy, churn prediction, fraud detection, industry uses, health industry, drug research, weather forecasting, insurance, banking, and remote sensing. Then predictive analytics methods are basically the softwares relies on methodologies such as logistic regression, time series analysis, and decision trees. These three things helps you to go for final decision when you are preparing the trees and all.